right. We're not judging. Everyone just put your hands up. Corinne, do you have questions you want to see go over?
No.
Okay.
How did I say it wrong? How did I say it wrong?
Because he thinks he's right.
He's wrong.
He thinks he's right and he's
No,
wrong.
no, no, no.
So
Hands one more time because I didn't finish counting.
Can you make Sam go up there and do that? Takes you less than 15 seconds.
You know, Sam, shut it.
Alright, hey.
Let's focus. Number 1, describe the slope. This is going up and to the right, so positive. And then if we count, this is going up 1, 2, 3, 4, over 2, which is
We both got it wrong.
So you need to have both positive and m equals 2 for that answer. Okay. Questions there? 4. This one can be done on the graph and in Desmos. I'll show you on the graph first. If we plotted this point negative 4, 1, and we have to write an equation that's parallel, we have to remember that this means the same slope, which would be a slope of 2. If I use my slope and go backwards, I go up 2 to the right one as many times as possible. And that equation would be y equals 2x plus 7. That would be parallel to the original.
Wait, you do something other than 7?
No. It has to be 7. From the graph, from Desmos, from algebraically, all of them should give you 7 as your y sub. You could use your point slope. In Desmos, you could type in the ordered pair. Type in your y equals mx plus b. Add in all your sliders. Change your m to be 2. And then move your b until it goes to that one. Which would be at 7. So whether you use the graph or use Desmos, make sure you write, use graph, use Desmos. Or if you did it algebraically, that's fine. 5, I'll put it into Desmos first. You could graph this using Desmos, negative 2x minus 3. So this should start at the y-intercept of negative 3, have a slope of negative 2, be a solid line shaded above. So on the graph, this would look like.
What are you trying to get at? You don't want to be
Guys, focus.
You got it wrong too long.
I was in the right direction.
It would look something like that. So make sure you have that. Be checking yourself in Desmos, as that's what the iPads are there for. Questions on that? If you don't already have your notes out, take those out from yesterday. And also the notes from a couple days ago, the difference of squares GCF notes. I forgot there was one thing that we needed to talk about, difference of squares wise. You can put the iPads off to the side. We're going to continue continue the notes from yesterday, but also talk about this.
These ones from yesterday, right?
I don't know for me.
That was so racist. Oh, you're racist.
Somewhere where you have space, I want you to write down these two problems. That could be on the new notes, on the old notes, on a piece of paper, it doesn't matter. Somewhere where you have space, write down these two problems. This goes with the difference of squares piece, but it's just a little bit more complex because of the fractions. But we're still doing the same thing. Except when you do difference of squares with the fractions, you have to think about, are both of these perfect squares? Could I find something that multiplies to this, the same something for this part, the numerator and the denominator, for both pieces? So what times what would give me 1? What times what would give me 9? And then what times what would give me n squared? And then we just figured out that that would be 1. And then what times what will give me 25? 5. Plus minus. So that part works the same. It's just they're now fractions instead. I'm trying to remember something else from this if I need to change that again or not. Alright, so then how would we write this one? Over 5.
Yeah.
Keep going. Okay. Keep going. 3 over 10. Plus minus. If you wanted to practice more problems like this, you could make up any perfect square. So if you think about all of your perfect squares, 1, 4, 9, 16, 25, 36, 64, 81, 100, keep going. You could mix any of your fractions and do this with any of your exponents as well. Questions on this? I need you guys to focus together. Do you have questions on this? Okay, now we're going to do the grouping. So find your grouping notes. We're going to walk through the example first and then do some of the other examples. So with your factoring by grouping, you'll see that we have 4 terms. We have polynomials. So before we were dealing with any amount of polynomials for GCF, difference of squares was binomials. Grouping is polynomials specifically for terms. So we're going to group the first and last term, so you can either put them in parentheses or just split it down the middle. When you split it down the middle, you want to make sure the sign of the third term goes with the rest of the right side. And then we're going to factor out the GCF of both sides separately. So on this side, x cubed plus 7x squared, what do those have in common? X squared. So I'm going to divide out x squared. I'm rewriting that I'm dividing just to show you all the steps. So that will go on the outside. What would be left when we divide that? X plus 7. And then on the right side, what do those have in common? What did we divide out?
2.
2. Whatever this sign is, you're going to bring that down. So you're dividing by a positive 2. What would be left? X plus 7. What do you notice about this so far? They both have the same thing inside. That's what you want. If that is not the case, something you did is wrong. So even while you're doing this, you could assume what the other part should be, but still do the work to make sure you get the same thing. Both should be the same. Whatever it is, both should be the same. So then once you have that, you're going to take whatever's on the outside, and you're going to put those together in a set of parentheses. Then the insides are the same, so you don't need to write this twice, you just need to write one of them. And that would be your second factor. And then if we wanted to double check ourselves, we could distribute FOIL, Box method, this back out to see did you get the same thing. So x squared times x, x to the third power, x squared times 7, 7x squared, 2 times x, 2x, and then 2 times 7, 14. This looks like this, so we know we did that right. So this really is just GCF doing it twice, but then rewriting it. So as long as you're good with GCF, you should be good here. But let's practice some more. What questions do we have about this before we do any others? Alright, let's start with number 1. Same thing, split it down the middle by either grouping this in parentheses or just drawing a line.
Wait, so we always draw the line after the 2?
After the first 2, yes. And then find what could be divided out of these first 2.
3x squared.
3x squared. I'm not writing that I'm dividing each piece, but you can still do that. I just won't have enough space. If I divide both of these by 3x squared, what's left?
X plus 5.
X plus 5. And then of the last part, what could we divide out of there?
2.
2, but it's going to be a negative 2, because we're going to bring down that negative. So divide each piece by a negative 2. The signs are going to change. X
Plus 5.
plus 5. The insides are the same. So then we're going to bring the outside pieces together. What would that factor look like?
3x squared minus 2.
Minus
X plus 5.
4, great, really great. And then the other one.
X plus 5.
And if we distributed that back, we're not going to actually do it, but I'll walk through it. This would be 3x cubed, 15x squared, negative 2x, negative 10. So that's any questions so far? Let's do number 2. After we split it down the middle, what's our first step? When you say both, which ones do you talk about? The first 2 by 2x. Is it the highest? 4x. I'm gonna do the 2x so we again see what would happen.
Do we have to write this?
You could do the 2 or the 4, it doesn't matter. Actually, it's not gonna be the same. So I'll make up another problem at the end. We'll just do the 4. And then if we divide out 4x, what's left?
2x plus 3.
2x plus 3. And then
Minus.
it's going to be a plus, because this one is a plus.
This y.
Do they both have a 2?
They have a 1.
Yeah, they both have a y, not a 2. So we can divide them both by y,
2x plus 3.
which would leave us with 2x plus 3. And then our two factors would be what?
4x plus
4x plus y
1.
and
2x plus 3.
2x plus 3. It doesn't matter if you put the outside factor first or second, as long as you have them both. Any questions, confusion so far? Let's skip down to number 4. Walk me through that. How would we start that?
Divide
X to the power to the power.
x cubed.
What has x cubed?
Oh, the first two.
Okay, so then we're doing what with that x cubed?
We're dividing.
Okay. And then if we're dividing that, then what?
X plus 4.
I heard x plus 4.
Wait.
We
Wrap
have
it up.
this, right?
With the parentheses, okay.
And then x to the
Plus, I'm hearing different things. I heard a plus, I heard x to the 3, but not where that goes.
Do you add
3.
You divide to
2. Are you dumb?
That was different things, sorry. What did you say and then what did you say?
you divide the both the 2 and the 8 by 2.
Okay.
The second one.
And then Luca, what did you say? Okay. So we have x to the 3rd, parentheses, x plus 4. And then
No.
put a 2.
And then
X plus 4.
X plus 4.
Okay, and then what?
And then X to the
Put
3rd
comma.
power plus 3.
X
In parentheses.
In parentheses, okay. Kareem, pay attention.
And then in parentheses again, X plus 4.
So make sure you're dividing both pieces, that you're keeping your parentheses, that you're putting things on the outside. Don't lose your GCF pieces. Look at the other problems on this page. Which ones do we want to see? Do go over, have questions about?
Number 8.
8. Any others? We'll do 8 and go on to the back if you have any of those, and then I'll attempt to make up one. So if we split this down the middle, what do the first two have in common?
2xy.
2,
X.
x, and y, all three of those things. We're dividing by 2xy. What's left?
X plus 3.
Okay. And what could we divide out of the last two? The negative 1. If you can't divide anything, you could always divide out a 1, and in this case, it's going to be a negative 1.
X plus 3.
X is plus 3, because you're dividing out the negative. The signs would change. So then what would your final two factors be?
2xy
2x.
in parentheses and then X plus 4 in parentheses.
Then instead, go on to the back. Any of those we want to see you go over and have questions about. So the back should look like this.
We do 12.
Alright, we'll try 12. Split that down the middle. What can we divide out of the first two? X squared. What would that leave us with? Y squared minus 3. And then for the second part,
2.
2. Positive 2. We divide that out, what's left?
Y squared.
Minus 3.
Yeah.
Okay, and then our final factors.
X squared plus 2.
And then Y squared
I said this, but I could have not when we were doing difference of squares. If you got a grouping factoring problem, and then at the end this was like 4 or 9 or something like that, you would have to factor this again. So as many times as you can factor it, you have to do that completely. But because 3 is not a perfect square, that would stay the same.
Where's the leg?
So if this was y squared minus 4 instead, we'd have to break that down into y minus 2 and y plus 2. And break this down. So you have to factor it completely, using all of your factoring methods. Now I made that up, so that wasn't actually part of the answer. You may also see something where you had a GCF at the beginning, and maybe the numbers were bigger, so I'm going to attempt to use one of these and just make the numbers bigger. So if I had something like this, we're gonna do it like normal first, and then see what happens at the end. So write that problem down so you have space.
Minus 1. Negative 1.
Which part?
Negative 1 yours.
Negative 16 RS.
Oh.
Oh.
Oh. Well,
It's okay. Okay, so if we split that down the middle, what do these two have in common?
8
In a R.
and S.
So, okay. Divide those, what's left?
R
Minus
2.
Okay.
It's okay. Alright, and then what can we divide out of the last two?
6.
Positive or
Negative 2.
negative?
Yes.
Which would leave us with
R plus 2.
minus 2. We're dividing by a negative.
Jeez.
So then at the end we'd have 8RS minus 6 and R minus 2. Are both of these prime? No. So what could we divide out of these two?
2.
What is
No.
Oh.
So because we can divide this by 2, we have to bring that out.
Oh.
And what would be left?
It's 3.
Now these are prime. So you could do this at the beginning or at the end. So at the end I see this is not prime, I have to factor it out again. But I also see at the beginning, I could have divided each of these by 2. If we had done that, it would have made this simpler. It would have actually just reverted back to this. And then you would just do the grouping with this and keep bringing down that 2 on the outside. So you could either do that first or do it at the end. It has to be done eventually.
But what if you divided the 8 and the 16 by 2?
So you could do that, but then it wouldn't get the same insides. And that wouldn't be the highest number.
Oh, that would be wrong.
Yes. Okay. Other questions on this page? Let me fix that thing. It wouldn't necessarily be wrong. These wouldn't match, so you'd have to keep dividing by 2 until you got them to match. But if you left it like that, it would be wrong. Okay. So we have now covered 4 different types of factoring. GCF, difference of squares, when A equals 1, trinomials, and grouping. There's only one more, and we're going to do that when we get back from spring break. But remember that you do have 2 Delta Maths due Friday. Your SOL 6A, 6B that's due when we get back. Your JLabs, practice, be working on any of that for the remainder of class.